Hey students, we are doing the paper 4 of February-March year 2024. So let's start. We have done the first two questions. So you can go to go to my previous video for the first two questions. I will link it at the end of the video, the first two questions. And now we are starting with question number 3. So let's start it. The question is about acid, bases, and alkalis. So we have some pH values here of the substances. Define the term base. We have to define the term base. Base is simply a proton acceptor. State what is meant by the term alkali. So alkali is a soluble base. A soluble base is called alkali. Thymophyllene is an indicator. State the color of thymophyllene in sodium hydroxide and acid. Ethanoic acid. The sodium hydroxide is an alkali and the CH3COOH is ethanoic acid. So the thymophyllene color in sodium hydroxide is blue. In alkaline solution, it is blue. And in acidic solution, it is colorless. Use the information in table to identify the substance with the highest concentration of H positive ions. So here, the highest concentration of H positive ion will indicate that the substance is most acidic. Highest H positive ion is equal to strongest acid. And the strongest acid has the lowest pH. So here the lowest pH is of NHNO3, which is nitric acid. So nitric acid has the lowest pH. That means it has the highest concentration of H positive ions. So the highest concentration of H positive ion will be of nitric acid, HNO3. And the explanation is because it has the lowest value of pH. Name an indicator which can be used to identify the substance with the highest concentration of H positive ions. So, name an indicator which tells us the strength of an acid and a base is universal indicator. Which universal indicator is the indicator which not only tells us about the acid and base of a substance, but it also tells us that if a substance, if an acid or a base or alkali is weak or strong. So in short, it tells us the concentration of H positive or OH negative ions in a solution. So this is universal indicator. By changing the color, it tells us that. Complete the equation to show the dissociation of ethanoic acid. Now, ethanoic acid is a weak acid. And when weak acids dissociate, their dissociation is always reversible. So we use the sign of reversible reaction. And when they dissociate, H positive will come out. So the rest of the thing will be CH3COO negative. And then we have H positive ion, which gets separated out. Write the ionic equation, which represents a neutralization reaction of any acid and any alkali. So, from any acid, we get H positive ion. From the alkali, we always get OH negative ion. And when H positive and OH negative combine with each other, they form H2O. So that's the ionic equation for every neutralization reaction. You have to remember this thing. H comes from acid. OH comes from alkali, any alkali. You can take any acid, any alkali, and they form a neutral water. This is the reaction. This is the ionic equation for the neutralization reaction. Then we have this moles question. Dilute nitric acid reacts with calcium hydroxide, and the reaction is shown. So this is the reaction. 20 centimeter cube of 0.0150 0 mole per decimeter cube calcium hydroxide reacts with 25 centimeter cube of nitric acid. Calculate the concentration of nitric acid in gram per decimeter cube. So here we have been given the volume and concentration of calcium hydroxide. And they're asking us to calculate the volume is given and calculate the concentration of nitric acid. So it means we have to deal between the two reactants. First, information is given of calcium hydroxide, and for nitric acid, the concentration is required. So the first step is calculate the number of moles of calcium hydroxide. We'll do it by using the formula. Moles is equal to volume into concentration divided by 1000, because the volume is given in centimeter cube. 20 multiplied by 0.0150 divided by 1000. And the answer comes out to be 0.0003. Next is determine the number of moles of nitric acid. Now, if we have the number of moles of one substance and we have to calculate the number of moles of the second substance, we'll take the ratio. So here we'll take the ratio between calcium hydroxide, number of moles of calcium hydroxide and nitric acid. First, we'll take the ratio from the equation. You can see in the equation that calcium hydroxide is 1 and nitric acid is 2 moles. So if one is reacting with 2 nitric acid, then 0.0003 calcium hydroxide will react with how much? We'll multiply it with 2 and the answer comes out to be 0.006. Next is calculate the concentration of nitric acid in mole per decimeter cube. We'll calculate the concentration. Now, whenever they ask us about the concentration, we'll use the formula. Moles is equal to volume into concentration divided by 1000. We'll use this formula. The number of moles we just calculated. Number of moles are 0.0006. Volume is given in the question, which is 25. So volume is 25. Concentration we need to find, divide by 1000. So when we do the calculation, 0.0006 multiplied by 1000, divide by 25, the answer comes out to be 0.0240. And when we want to convert this mole per decimeter cube into gram per decimeter cube, just convert the moles into grams by using the formula. The formula here is moles is equal to mass over molar mass. We'll always use this formula when we have to convert moles into mass. The moles here are 0.0240. We need to find the mass, the grams, mass in grams. And the molar mass of HNO3 is HNO3. Its molar mass will be hydrogen is 1 plus nitrogen 14 plus oxygen 16 into 3 and nitric acid is 63. We'll take it on this side and multiply. The answer is 1.5, 1.51. 1.51 gram per decimeter cube is the concentration of nitric acid. Okay, next question. The equation for the reaction between methanoic acid and ethanol in the presence of a catalyst can be represented as shown. So we have here this methanoic acid and this is ethanol and is giving X plus water. Delta H is given, which is minus 29.5. It means that the forward reaction is exothermic. X represents the ester. In the equation, methanoic acid is represented by the formula HCOOH. Name this type of formula. Now, this formula is called structural formula. Write the empirical formula of methanoic acid. Empirical formula is the simplified formula. So we will simplify methanoic acid. Methanoic acid is CH2O2. Now, as you can see that this formula cannot be simplified, so the same molecular formula will be the empirical formula also. Otherwise, if it could be simplified, then we will simplify and then write it over here. Name and draw the displayed formula of ester X. Now we'll make the ester X. First of all, its name. The name of the ester uses the name of the alcohol and carboxylic acid both. The alcohol name will change into yle, so ethanol will change into ethyl, and methanoic acid will change into OH. So the name will be ethyl methanoate. Ethyl methanoate, and then we'll draw its structure. First, we'll draw methanoate. So methanoate, meth means 1 carbon, eth means 2 carbon. Meth is 1 carbon, so 1 carbon, double bond O, O. So in methanoate, there will be 2 hydrogens like this. So this is methanoate, which we drew. And then we have ethyl attached with it, 2 carbon. So this is ethyl. The reaction is reversible and reaches equilibrium in a closed system. State what is meant by the term closed system. The closed system is the system in which no reactants or products can leave or enter the system. State 2 characteristics of an equilibrium. Now, in an equilibrium, first of all, the rate of forward and backward reactions are equal. Forward and reverse reactions are equal. The second is that the concentration of reactants and products is constant. Concentration of reactants and products is constant. Or constant. So these are the 2 features of an equilibrium. Next, complete the table to show the effect, if any, on the concentration of X at equilibrium for each change of the condition. Now we have to see the reaction, that if we change these conditions in the reaction, that what will happen to the position of X, which is ester. So if the reaction moves forward, then the ester concentration will increase. And if the reaction moves backward, then the X concentration will decrease. So let's write the equation here for the simplicity. HCOOH. Okay. So the equation is HCOOH plus CH3, CH2OH gives ester X plus water. And the forward reaction has the delta H minus 29.5. Minus 29.5 kilojoules per mole. So it means that the forward reaction is exothermic. Now let's see. If the temperature is decreased, if we are lowering down the temperature, then the system will move towards the exothermic side. And the exothermic side is the forward side. So it will move forward and the X concentration will increase. It's a reversible reaction. So the X concentration will increase. Next is that the concentration of methanoic acid is decreased. Now, if we decrease the concentration of methanoic acid, then system will move towards the side where the methanoic acid is formed. Because system will always do whatever we do, it will do the opposite. So if the concentration is decreased, if we decrease it, if we make it low, then system will move towards the side where the concentration is increasing, where the HNO3, where the methanoic acid is formed. So it will move backward because on backward side, methanoic acid is produced. So when it moves backward, then the concentration of ester will decrease. Same with the other one also. In the next one, it's written then when methanoic acid and ethanol are decreased, both of them are decreased, then system will move towards the side where both of them are produced. So again, it will decrease. The catalyst is removed. Now, catalyst has no effect on the position of equilibrium. So there will be no change or no effect. Next question is butane and but1-ene are colorless gases at room temperature and pressure. State why but1-ene diffuses quicker than butane. Now, diffusion depends upon the molecular mass. Diffusion depends upon the molecular mass. So if any substance is diffusing quicker, so it means that its molecular mass will be low. So it has low molecular mass than butane. Identify the products formed when butane undergoes complete combustion. So whenever any fuel undergoes complete combustion, it produces carbon dioxide and water. It is all carbon dioxide and water are always produced whenever anything and whenever anything or any fuel has undergone combustion. One molecule of butane reacts with one molecule of chlorine in the presence of ultraviolet light. During the reaction, one hydrogen atom in butane is replaced by one chlorine atom. So this is butane is an alkane, and when alkane reacts with chlorine, then there is a specific type of reaction in which chlorine displaces one of the hydrogen of an alkane. So name this type of reaction. This type of reaction is called photochemical reaction, which needs ultraviolet light. State the purpose of ultraviolet light in this reaction. The purpose of ultraviolet light is to provide the activation energy for the reaction. Name the type of reaction which takes place when 1 mole of chlorine replaces 1 atom of hydrogen. Now, this type of reaction is called substitution reaction. And this is a kind of displacement reaction in which a chlorine displaces hydrogen from an alkane. So I'll write it here. That substitution reaction is an example or it's a type of displacement reaction. Determine how many different structural isomers can form during this reaction. Now, the type of structural isomers will be 2, because when butane reacts with chlorine, then it forms chlorobutane. It forms chlorobutane. When chlorine displaces one hydrogen from the butane and take its place, it will form chlorobutane, and butane is 4 carbon compound. So there are 2 possibilities. It will form 1 chlorobutane and 2 chlorobutane. So these are the two isomers which can form from the substitution reaction. So the two isomers, 1-chloro and 2-chloro. When but1-ene reacts with steam, two possible products formed. Identify the type of the catalyst which is used in this reaction. So the catalyst which is used in this reaction is acid. Any acid. When butene reacts with steam, this is the other type of reaction. This is not substitution. In this, the double bonded structure, the alkene, is reacted with steam or water. So this is like the addition of water into the alkene. So it requires acidic conditions. The main catalyst which is used in this reaction is phosphoric acid. So in the answer, you can write phosphoric acid, or you can also write simply acid. You will get the marks. Name the product and the displayed formula of the two possible products. So the two possible products which are formed in this reaction, alcohol. When but1-ene reacts with water or steam, then it forms butanol. So there are again two possible isomers. There can be butane-1-ol, and the second product will be butane-2-ol. And let's draw the structures of both of them. Butane-1-ol will be butane 4-carbon, and on one carbon we will attach alcohol, OH group, and then we'll complete the rest of the valency of carbon with hydrogen. Similarly, we'll draw 4 carbons of butane-2-ol, and on the second carbon, we will attach this OH, and then we'll complete the rest of the valency of carbon using hydrogen atoms. But1-ene undergoes polymerization. State the type of polymerization. That's addition. Because in addition polymerization, the monomers are always alkenes. Draw the part of the polymer molecule to show 3 repeating units. Now, to form the polymer from but1-ene, first we have to make one butene, and we will see that how monomer will look like. So here, first 1, 2, 3, 4. So but1-ene will look like this. So it will be CH2, CH, CH3, CH3. So we have to focus on this carbon-carbon double bond. So we'll shift the rest of the things up and down. So it will be carbon double bond carbon. On the first carbon, we have 2 hydrogens, so we'll make them up and down. And on the second carbon, we have 1 hydrogen attached up, and then there is 1 C2H5 attached. So we'll write it here, C2H5. So it means this is the monomer. This is the shape of the monomer of but1-ene. So we'll make its polymer. The polymer is formed by just opening of the double bond. So this is the first monomer, C2H5. First monomer. Same thing will repeat next as a second repeating unit, C2H5. And then we have the third repeating unit, with C2H5. This is the polymer with 3 repeating units. We have to make sure that we'll draw first monomer to identify that what will be the shape of the monomer in the polymerization. So once we get the shape of the polymer, we have to focus on the carbon-carbon double bond, and rest of the substances which are attached on the carbon will make them up or down so that nothing will be present on left or right side, and we can make the polymer easily. So that's the addition polymer. And our paper 4 of February-March 24 is complete.